Today's learning target is I can write fractions as decimals. The first thing we're going to take a look at here is to write a fraction as a terminating decimal. Terminating means ending, so it's a decimal that ends. So let's take a look at the fraction 7/8. Okay? Now remember, when we're dealing with fractions, the fraction line there means divided by. So when we want to find a decimal for the fraction 7/8, we're doing 7 divided by 8. Okay, and so we set it up like this. Now the mistake people sometimes make is they put the 7 right here. Okay, but remember, just say it to yourself, 7 divided by 8. What we're dividing by is always on the outside. Okay, now the key, once you set that up, okay, and you've got your 8 on the outside, your 7 there, is to put the decimal right there and add the 0. Okay, you can see they've done that right here. And if you don't remember how to do the division like this, ask me real quickly and I can go over that with you. You probably just need a refresher. But you can see once we divide this out that we eventually get to a point where we're left with 0. There's nothing more to bring down, and we have the decimal 8.875, or 875 thousandths would be the decimal for 7/8. If I find a terminating decimal on a calculator, I just have to make sure I type it in the correct order. So I'll get the same answer, and I'd type it in just like I'd say it, 7 divided by 8, because I'm taking 7 and I'm dividing those into 8 groups. So for this problem, let's take a look at writing a fraction as what's called a repeating decimal. So I have the fraction 5/12 here. Okay, now I set that up right here because it's 5 divided by 12. Okay, that sets up like this. Now when I divide this problem out, okay, here's my work, and we can see something interesting happens here. Okay, so I haven't finished this problem out, but we can see I had my 6 here. I did 6 times 12, that's 72, and now, okay, that gives me 8, and I'd have to bring another 0 down. Okay, now if we take a look, we're seeing we've got a repeating pattern here. If I continue to do this, I'm going to keep having the 12 go into this 80 6 times, and I'm going to have 8 left over. Once that happens, we have what's called a repeating decimal. Okay, and so I would write the fraction 5/12 like this. I would say as a decimal, that's 0.416, and I put what's called the bar notation on the top of this 6, because that means this 6 is going to keep repeating. So this right here is the decimal for 5/12. If you were to do that problem, that division problem on a calculator, okay, so that 5/12, you're going to see this sort of an answer. And you notice here, it's just going to give you as many 6s as your display will have. And the last one is going to round up right there. That's just your clue that the 6 repeats. Okay, so if you were writing that out, you would still write decimal 416. Okay, because that's what it would be as a decimal, and then you put the bar notation above it to show that it repeats. If this fraction happened to be negative 5/12, it's going to be the exact same answer, except it's going to be 416, put the bar notation for repeating, and you'll just put a negative sign there. Now my repeating sign's a little sloppy here. All you need to do is one line going across it. So here you can see in this calculator, I calculated the fraction for 1/11, so 1 divided by 11, and I get a different type of repeating decimal. So here I'm looking at 0.9, and the 0.9 is what repeats, okay? And you can see here at the end it just rounded it. But to show that the 0.9 repeats, I put the bar notation over what repeats. So over the 0.9, that's how I would write that. In your assignment today, you're also going to be asked to compare fractions and decimals. So when you do that, you want to get, it's easiest to get both of these into decimals. So we already have one decimal here, and we want to get then 1/4 into a decimal. So you may already know that 1/4 is 25 hundredths as a decimal. Okay, and if you know that, great, that's one less step to do. If not, you just divide it out just like we did, and that would get you to 25 hundredths. Now you can see what they've done here is they've annexed a 0 to 2/10. All that means is they added a 0 at the end of this decimal. You can always add zeros at the end of the decimal and it doesn't change the value. Okay, when we had 2/10, that's like 2 dimes. When we have 20 hundredths, it's like 20 pennies. It's worth the same. Okay, but once we have the same number of digits in the decimals, now it's easy to compare them. Now to compare these, I'm going to start at the place value that's the greatest. So I'm going to start at the ones place. They're both at 0. So I'm going to now move over to the tenths place. They're both at 2. So they're equal. So now I move to the hundredths and I see that I have 5 hundredths in one and 0 in the other. So 25 hundredths is going to be the decimal that's greater. So when you're doing your work today, it should look something like this here, where I've written out the original problem, and then I show my thinking. Okay, here's 25 hundredths as a decimal, and here's what it would look like here if I added a 0, and I just put my greater than sign. If I'm looking to compare these two fractions right here, notice they're both negative. Okay, the first thing I'm going to do is to figure out the decimal for each of those. So I've done that. We know how to do that part. Now, keep in mind here that we're dealing with negative numbers in this. Okay, and we know with negative numbers, okay, I've got a number line here. The farther to the right we are in the number line, the greater the number. Okay, and that tells us then the farther to the left, the smaller number. So negative 1 falls right here in the number line. Negative 2 is smaller because it's farther away from 0. Negative 3 is smaller than negative 1 because it's farther away from 0. So I changed my number line here to show the decimals. So we know negative 0.625. All right. Here's negative 0.5. Negative 0.625 is going to fall to the left of that. It's going to be smaller than negative 5/10. Okay, so I'll put a mark about right here for that. Now, if I look at negative 0.6 repeating, okay, so it's going to fall very close to this one because I see it's 6/10 in both of the tenths place. I see it's 2/10 here and 6/10 here. Remember, it's negative, so it's going to fall slightly to the left. Okay, so that's going to fall about right here on our number line. So I know then that this number is smaller. So to show that, I'm just going to use my greater than sign, and that's how it would look.